Good day, week 3 of CS442. Let's take a quick look at the schedule to see where we should be. Scrolling down a bit, right here is week 3, read module 3. More importantly, next week is when assignment 1 is due on Wednesday, and exam 1 between that Wednesday and, Saturday by noon. Please don't ruin your Saturday by doing an exam. I'm just trying to give you a wide range of time when you can do it in. The exam is not supposed to take that long. By the way, because a student asked, I give you a 3-hour window to take an exam. God, don't take it 3 hours for all 5 of these exams, please. I give you a 3-hour window just in case there's connection issues or anything like that. It's not because I expect the exam to take 3 hours. Good God, don't take 3 hours on the exam. Each exam, how much time it takes, you can take really as much time as you want, but these 5 exams are really supposed to be a bit less than 1 midterm and 1 final. After all, it's 25% of your grade, so each of these is only 5%. Think of it in that way. How long should you take on 5% of your grade? You have 3 hours. That's just in case there's connection issues or anything like that. It should take a lot less than that. More to the point, of course, this week, read Module 3. Now that, of course, means hopefully you've read through modules 1 and 2, and I realize as there hasn't been anything due yet, it's a bit hard to stay on track and keep up with the reading. I know you can feel like, I'll read it all 5 minutes before the exam. Don't do that. Don't do that. It is very difficult to stay on topic, and also, this is kind of heady stuff. It's hard to digest. It takes a while to just think about it. So now you've seen Module 2, which was on the lambda calculus. And maybe you're thinking, what's the point? Why are we looking at this lambda calculus thing? Some students try to sort of think of the lambda calculus as a programming language, and they go, how would I actually do things in the lambda calculus? And the answer is you don't. You can. It is Turing complete. You can build complicated things out of the lambda calculus, but it's bizarre. It doesn't really match how a real computer works. It's really just a way of thinking about functions, and it's almost just the observation of the fact that functions are all you need to be Turing complete, to be as powerful as a Turing machine, which is a bit of a surprising result. It's sort of a surprise that you don't need numbers. You can build numbers out of functions. You don't need Booleans. You can build Booleans out of functions. You don't need anything. You just need functions. Functions are powerful enough. And that's kind of the beauty of the lambda calculus. It's not that it's good. It's not a programming language. It's that it's shockingly powerful given that it's nothing. Having that kind of a foundation and being able to describe very precisely, here's what functions are, here's how functions might work, gives us the ability to build more on top of that. And that's what we start in Module 3. So in Module 3, you'll look at formal semantics, and that is a formal description of how code runs. And we'll start with a formal description of the lambda calculus as if it were a programming language. As we move on through the course, as we look at other paradigms, we will build semantics for those programming paradigms. We will build formal descriptions of how a program might run in a functional programming language, a logic programming language, an imperative programming language, object-oriented, concurrent, or a systems programming language. We will talk about how all of those affect how a program runs and how you describe that formally so that you can prove things about languages. We are connecting this mathematical model to real programming languages. The hope is that this justifies some of the more seemingly esoteric math you might have seen before, because this is really the foundation of how we prove anything about computers, how we prove that anything we do is ever right or ever makes any sense at all. This connection between mathematics and actual software and programs, we need that kind of connection. Otherwise, it's all ad hoc. It just comes together as we go. Now, I love things that are ad hoc, but sometimes it's valuable to have that kind of connection as well. So, You've seen in Module 2 lambda calculus, you'll see in Module 3 formal semantics. I do want to say we are pretty early in the course here. If you are really struggling with Modules 2 and 3, you're going to struggle a lot with this course, because the language of formal semantics, if you can describe that as a language, is how we're going to talk for this entire course. Almost everything we build is going to be built on top of the lambda calculus, or we'll presume that you understand the lambda calculus. It's not that you should be comfortable programming in the lambda calculus, it's not a programming language, but you should understand how it runs and maybe even have a bit of an intuition for why it's Turing complete or why it's so powerful, even though all it has is functions. It's a surprising thing, and we don't really ask you to prove it, but you might want to get that kind of intuition because as we build other languages, being able to see, aha, this is the point where this is Turing complete, can be valuable. So if you're really struggling a lot with Modules 2 and 3, come talk to me. I can try and give you other perspectives on it, other ways of thinking about it, because if you don't have those fairly solidly, you're going to struggle a lot with the rest of the course. So, Module 3 for next week, Module 4 is already posted, Module 5 is longer, that's why you have 2 weeks to read it. I haven't finished it yet. It will be up before you need it. I definitely will have all the modules up before you need them, but I'm not going to make any stronger promises than that. Module 5 will span reading week, so you have plenty of time to go over it. It is the first of our paradigm modules exploring functional programming, and from there we'll look at many other programming paradigms, in each case relating it back to formal semantics. Thank you for watching. See you next week.